How big is the universe really? It sounds like a simple question, but the answer is almost impossible to truly imagine. We are used to understanding size through familiar things: a large city, a tall mountain, a vast ocean, or even an entire planet. But when we start talking about the universe, ordinary human ideas of size begin to collapse. Because the universe is not just big. It is so enormous that even light, the fastest thing in nature, has not had enough time to show us all of it. To understand the scale, we should begin close to home. Earth feels huge from our point of view. A plane can fly across an ocean for many hours, and a person can live an entire life without seeing even a small fraction of the planet. But in cosmic terms, Earth is almost nothing. Light from the moon takes just over 1 second to reach us. Light from the sun takes about 8 minutes. That means when we look at the sun, we do not see it exactly as it is right now. We see it as it was 8 minutes ago. Light from Mars can take from a few minutes to more than 20 minutes to reach us, depending on where Mars is in its orbit. And for the outer parts of the solar system, light needs hours. And this is only our solar system. In diagrams, the planets are often shown close together, almost like they are lined up neatly beside each other. But in reality, the distances between them are enormous. Most of the solar system is empty space. Neptune, the most distant major planet, is so far away that sunlight takes about 4 hours to reach it. The Voyager 2 spacecraft needed many years to travel far enough to fly past it. But even beyond Neptune, the solar system does not simply end. Far away, there are icy bodies in the Kuiper Belt. And even farther out, there may be the Oort cloud, a huge region of comets stretching toward interstellar space. Only after that do the distances between stars truly begin. The nearest star system to us is Alpha Centauri. Light needs more than 4 years to travel from Alpha Centauri to Earth. 4 light years may not sound terrifying until you remember that light travels at almost 300,000 kilometers per second. In 1 second, light can travel around Earth more than 7 times. In 1 year, it travels about 9.46 trillion kilometers. And even at that speed, reaching the nearest stars still takes years. If humans tried to travel to Alpha Centauri with the fastest spacecraft we have ever built, the journey would take tens of thousands of years. And that is only the nearest star. Our galaxy, the Milky Way, contains hundreds of billions of stars. It is so large that light needs about 100,000 years to cross it from one side to the other. 100,000 years. When light begins traveling from one edge of the Milky Way toward the other, entire civilizations could rise and disappear before that light finishes its journey. Our Sun is only one ordinary star among an enormous number of others. It is not at the center of the galaxy. It is located in one of the spiral arms, far from the dense central region. If the Milky Way were a massive city, the solar system would be like a small house somewhere in the suburbs. Not the center, not a special place, just one point among countless others. But even the Milky Way is not the whole universe. Near us, there are other galaxies. The most famous is Andromeda, located about 2.5 million light-years away. That means the light we see from Andromeda today began its journey before modern human civilization existed. It traveled across space for millions of years before finally reaching our telescopes. And Andromeda is only one neighboring galaxy. Galaxies gather into groups, clusters, and superclusters. Our Milky Way, Andromeda, and many smaller galaxies belong to the local group. And the local group itself is part of even larger cosmic structures. On the largest scales, the universe looks like a cosmic web. Galaxies gather along long filaments and walls, while enormous empty regions, called cosmic voids, stretch between them. Some of these voids are so large that there are very few galaxies across hundreds of millions of light-years. Imagine a region of space so vast that even galaxies become rare particles of dust within it. And yet, this is still not the full scale. When we talk about the size of the universe, we have to separate two ideas: the observable universe and the entire universe. The observable universe is the part of space from which light has had enough time to reach us since the beginning of cosmic expansion. Its radius is about 46.5 billion light-years. That means the observable universe is about 93 billion light-years across. At first, this sounds impossible. If the universe is about 13.8 billion years old, how can the observable universe be 93 billion light-years wide? The answer is that space itself is expanding. While light from distant galaxies was traveling toward us, the space between us and those galaxies was stretching. Because of this, the objects whose ancient light we see today can now be much farther away than 13.8 billion light-years. This is one of the strangest ideas in cosmology. The universe is not expanding into empty space like an explosion. Instead, space itself is stretching. So when we say the observable universe is 93 billion light-years across, we are not talking about the full universe. We are only talking about the region we can currently observe. Beyond that limit, there may be more space, more galaxies, more dark matter, more cosmic voids, and more regions whose light simply has not reached us yet. This means the edge of the observable universe is not a wall. It is not the end of reality. It is only the limit of what light can show us. So how large is the entire universe? We do not know. It may be much larger than the observable part. It may be hundreds or thousands of times larger. It may even be infinite. If the universe is infinite, then it does not have a total size in the ordinary sense. There is no last galaxy, no outer wall, no final edge where space ends and something else begins. Space simply continues. This is extremely difficult for the human mind to imagine. We can say the word infinity, but truly understanding it is another matter. We are used to things having boundaries. Roads end. Oceans have shores. Rooms have walls. Even planets have surfaces. But the universe may not work like the objects we know. Another possibility is that the universe could be finite, but still have no edge. That sounds impossible, but there is a simple analogy: the surface of Earth. Earth's surface has a limited area, But if you travel across it in one direction, you do not fall off an edge. You can eventually return to where you began. The universe could have a more complex version of this idea. Space itself might be curved in such a way that it is limited, but has no boundary. Today, observations suggest that space in our observable region is very close to flat. But that does not prove the entire universe is infinite. It may simply be so large that we cannot detect its curvature from our small observable region. It is like standing on Earth and seeing flat ground around you. Locally, the surface looks flat, even though the whole planet is curved. The same may be true of the cosmos. The part we can observe may look flat, while the full universe could have a much larger shape we cannot measure. Another reason the size of the universe is so hard to understand is that the universe is not standing still. It is expanding. Distant galaxies are moving away from us not because we are at the center, but because the space between galaxies is stretching. The farther away a galaxy is, the faster the distance between us and that galaxy tends to grow. On the largest scales, this expansion can become so strong that light from some regions will never reach us. This means there may be galaxies that exist beyond our cosmic horizon forever. Even if they are real, even if stars are forming there, even if planets exist there, we may never see them. In the far future, if expansion continues, many galaxies may disappear beyond the observable horizon. Future observers could see far less of the universe than we can see today. That is a strange thought. The universe may be enormous, but the part accessible to it can change with time. We live in a special moment of cosmic history when we can still see distant galaxies and ancient traces of the early universe. One of those traces is the cosmic microwave background. This is the oldest light we can observe. It comes from a time when the universe was very young, about 380,000 years after the beginning of its hot early state. Before that time, the universe was so hot and dense that light could not travel freely. But when the universe cooled enough, light was finally able to move through space. Today, we see that ancient light as a faint microwave glow coming from every direction in the sky. It is not the edge of the universe. It is the limit of how far back in time we can see using light. So when we look into deep space, we are not only looking across distance, we are looking into history. Every telescope is a kind of time machine. Light from distant galaxies shows us what they looked like millions or billions of years ago. Some of the galaxies we observe may have changed completely by now. Some may have merged with others. Some may have faded. Some may no longer exist in the same form. We see them not as they are today, but as they were when their light began the long journey toward us. This makes the universe large in two ways. It is large in space, and it is large in time. When we say the observable universe is about 93 billion light-years across, we are describing an enormous sphere around us, filled with an unimaginable number of galaxies. The exact number of galaxies is still debated, but estimates suggest there may be hundreds of billions, and possibly even trillions, within the observable universe. And each galaxy may contain billions or hundreds of billions of stars. Around many of those stars, there may be planets. So when we ask how big the universe is, we are not only asking about distance, we are asking about the number of possible worlds, histories, and unknown places that may exist beyond our imagination. And all of this is only the observable part. The entire universe may be so much larger that our visible region is like a tiny drop in an ocean. Or perhaps the ocean is infinite. We do not know. But that is what makes the question so powerful. The size of the universe is not just a number. It is a boundary of human knowledge. We can measure distances to galaxies. We can map the cosmic web. We can study the cosmic microwave background. We can estimate the shape of space, but we cannot step beyond the observable horizon and look at what lies farther away. We live inside the universe, on a small planet, near an ordinary star, in one galaxy among countless others. And yet, we are able to ask questions about the scale of all existence. That may be one of the most extraordinary things about the human mind. We are small, but we can think about the infinite. So how big is the universe really? The observable universe is about 93 billion light-years in diameter. But the entire universe may be far larger, maybe hundreds of times larger, maybe thousands of times larger, maybe infinite. And if that is true, then every galaxy we see, every star, and every beam of ancient light is only a tiny fragment of a reality stretching farther than any telescope, any journey, or any imagination. The universe is not merely big, it may be larger than our very concept of big itself.